Hey guys, this video is just going through the application examples from pages 14 through to 16 of our notes from today. So firstly, we're looking at a VCAR question from 2020, so from last year's paper. And we're starting off with three major shopping centres in a large city. East Mall, Grand Mall and West Mall are all owned by the same company. The total number of shoppers at each of these centres at 1 p.m. on a typical day is shown in matrix V. And so we can see there that we've got E representing East Mall, G for Grand Mall and W for West Mall. So firstly, let's write down the order of matrix V. So a reminder, the order is asking for the size. We have one row and three columns, so our order is a 1 by 3 matrix. Then we're going with some new information. So each of these centres has three major shopping areas: food, clothing and merchandise. The proportion of shoppers in each of these areas at 1 p.m. on a typical day is the same at all three centres and is given as matrix P. So note these are proportions. So 0.48 would be the same as saying 48%. In part B, Grand Mall's management would like to see 700 shoppers in its merchandise area at 1 p.m. If this were to happen, how many shoppers in total would be at Grand Mall at that time? So how many shoppers in total is what we're after. So at this point, we're just concentrating on the information that's on the screen at the moment. If we know that there are 25% of the shoppers in the merchandise area, and that 25% is equal to 700. So we're saying 25% of our total is going to equal 700. We can set up an equation to find out what must that total be. So I would convert that. I would use the proportion, 0.25. Remember, when we're finding a percentage of something, we'd multiply. And we know that that is equal to 700. And so when we solve that on our calculator, we get 2,800. So we want 2,800 total shoppers. Okay, part C, the matrix Q equals P times V, shown below. Two of the elements of this matrix are missing. So complete matrix Q above by filling in the missing elements. So we need to take our matrix P and V from above, multiply them using our calculator, and then fill in those gaps. So let's grab our calculator now and do that calculation. Okay, so entering matrix P first. P was a 3 by 1 matrix. And we can enter those values in, 0.48, 0.27 and 0.25. And we're wanting to multiply that by our matrix V. V was a 1 by 3 matrix. And we had 2,300, 2,700, 2,200. And if we just press enter, that'll do that calculation for us. So the two values that we were looking for were in column 2, row 1 and row 2. So we can go and transfer those values in now. Okay, so there's our values. The next part of the question is now asking the element in row I, column J of matrix Q is Qij. So we're used to that notation or that wording now. What is the element Q23 represent? So row 2, column 3 of our matrix in Q. It's asking, what does that number 495 represent? And so we want to read from that our row label and our column label. Okay, so our row 2, which would be clothing, and column 3, which is the West Mall. And so what does that element represent? It represents that there were 594 shoppers in the clothing section or the clothing area at West Mall. So note here, when it asks what does it represent, we don't want you just to tell us the number. We want you to tell us, using those row and column headings or labels, what is that actually representing. Okay, so continuing on over the page, we have the average daily amount of money spent in dollars by each shopper in each of the 3 areas at Grand Mall in 2019 is shown in the matrix A 2019 below. So we can see there in the food, the clothing and the merchandise sections. On a particular day, 135 shoppers spent an average daily amount on food. We had 143 shoppers spend the average daily amount on clothing. And we had 131 shoppers spent the average daily amount on merchandise. We now need to write a matrix calculation using A 2019 from above, showing that the total amount spent by all of these shoppers is $9,663.20. So at this point, they're asking you to do a matrix calculation, but first I want you to think about, well, what do I want to end up with? So in this case, they're telling us to find or to be able to show that calculation to get the total amount, which is that $9,663.20. So we want to end up with a single value, okay? So we want a single value, which means in a matrix form, we want a 1-by-1 matrix. At the moment, we need to use the 2019 matrix. So they've told us we have to use A. And A is a 3-by-1 matrix. So if we think about our rules around multiplication, we know that in order to end up with a 1-by-1 matrix, the outside numbers both need to be 1. The inside numbers need to match. So if I have to use this A 2019, that means when I'm multiplying, I've got to do a matrix times this A 2019 that will result in a 1-by-1. To make it defined, the number of columns in that first matrix has to be a 3. And to end up with the result I want, the number of rows needs to be 1. So I'm making a row matrix. So that's sort of the matrix side of it. If I said to you, you've got these daily spends and this amount of shoppers in each area, how would you work out the total amount that they spent? You're probably pretty comfortable that you would say, well, the 135 shoppers from who shopped in the food section were spending $21.30 each. So if I multiply those together, that gives me the total spent on food. Then if I do that with the 143 in the clothing section, so multiply that by the $34, and again, the 131 shoppers in the merchandise section by $14.70. If I add all of that amount together, I'm going to get the total 9,000 and so on. So here we are wanting to do some multiplying. So that leads us to this matrix multiplication here. So I know I've got my matrix A. I've said I have to multiply it by this row matrix, so 1/3. And so I'm thinking about here, remember anything that's in the first position, the start of the row, you're going to multiply by the start of the column when you're doing your run and dive. So that points me to put 135 as the first element there. If I follow along, my second element in the row and the column is what I want to multiply. So I'm going to put 143 here. And then finally, the third element in the row and the column, both relating to the merchandise, so the number of people purchasing from the merchandise, $131. Now, I want to check that and make sure I end up with the answer that they're asking for. So when I put that information into my calculator, I end up with a single value in my matrix of 9,663.2, which is the value that they wanted. So the marks attached to this question are solely around setting up that calculation. Okay, part E, final bit. So in 2020, the average daily amount spent by each shopper was expected to change by the percentage in the table below. Food is going to increase by 5%, clothing will decrease by 15%, and merchandise will decrease by 1%. So the average daily amount in dollars expected to be spent in each area in 2020 can be determined by forming the matrix product A 2020 equals K times A 2019. Write down matrix K. So again here, what do we know? We know that A 2019 is a 3 by 1 matrix. Our matrix for A20 has to end up the same size, okay, as a 3 by 1. So it's going to look very similar to the A 2019 at the top of the page, but just with some different spend values there. So in order to make that work, our matrix K has to have 3 columns so that it's defined, and to get 3 rows in our answer has to have 3 rows. So I'm constructing K as a 3 by 3 matrix. The second piece of information that I need before I can work out what K must look like is I need to take this information here about the change and convert that into, I guess, proportions. So I'm taking that percentage, and it's very much like what we did in finance where we were finding big R. So if you think about that geometric growth and decay, this is the exact same thing. If I'm increasing something by 5%, I'm doing 1 plus 5 over 100, which means I get 1.05. If I'm decreasing, I'm doing 1 minus, and this is by 15%, so 15 over 100 gives me 0.85. And then finally, my merchandise decreasing again by 1 over 100, so that gives me 0.99. Now, in order for this to take effect, if we just quickly pop in our 2019 values, 34 and 14. When I'm working through this calculation, what I want my value to be in row 1, column 1, I want that to be just the new spend in food. So I want to utilize this percentage and multiply that by my food amount. Okay. So I definitely want to put 1.05 here. But then if I was to move across my row and down my column, I actually don't want to add on anything from the clothing and the merchandise section. So in order to not add anything on, I need to multiply these values here by 0. So that means in my K matrix, I make it a 0 in column 2 and a 0 in column 3. Because that means I won't carry forward any of that value from the other areas. So if I think about it with the second one, the element here in row 2, column 1, I'm now working with row 2, column. I only want to adjust the $34 that is here in the second row. So if I'm moving through my matrix, I don't want to pick up anything from the first calculation from food. I definitely want to adjust my clothing. But then again, as I move across, I don't want to pick up anything from merchandise. So again, I make those other spaces 0, and they act like placeholders. Finally, I want to see my change in merchandise to go into that row 3, column 1. And again, I only want to decrease the merchandise value from 2019. So again, as I'm working across row 3, I don't want to pick up anything from food. I don't want to pick up anything as I move across to the second position from clothing. I do, however, want to do this multiplication in relation to merchandise. Okay? And so what we've actually formed here is a diagonal matrix. Okay? So K, in this case, will be a diagonal matrix. How we know to use those when we are adjusting just single pieces of a matrix that has multiple sets of information. So our final answer is just the component here, which is K. And the reason I knew I had to use a diagonal matrix is I first established that it had to be a 3 by 3 in order to firstly be defined, but then also to give me the result that I want, the size that I want. So that points me towards using a diagonal matrix, where only the things in the leading diagonal are going to have an impact. Everything else are zeros so that they create like placeholders. So that is one of the more challenging components of matrices, looking at that, particularly that last 2 questions there. But we want to get familiar with those applications so that you can feel confident when you get into your SACs and exams. Okay, example 2. So again, another VCAR question. This is taken from exam 2 from 2018 in the Northern Hemisphere. Question 1, so starting off the paper in this section. So a toll road is divided into 3 sections, E, F and G. And the cost in dollars to drive one journey on each section is shown in the matrix C below. So there we can see our 3 sections and the cost for each one. What is the cost of one journey in section G? So we're just looking at this value here. And so that's just testing, can you read a value from a matrix and interpret it? So $2.87. Write down the order of matrix C. So our size, we have 1, 2, 3 rows and 1 column. So nice and straightforward so far. One day, Kim travels once on section E. So once on section E and twice on section G. The total cost of his day can be found by the matrix product M times C. What is matrix M? So we want a total cost. So if we want a total cost, that means we want a single value. When we want a single value, the matrix that we end up with has to be a 1 by 1 matrix. So I want you to be thinking that. I'm looking for that. Total cost tells me the size my answer must be. In order for that to be a 1 by 1 at the answer, what we know at the moment is C is a 3 by 1, which means in order to get that 1 by 1 answer, we have to have M has 1 row, and in order for it to be defined, has to have 3 columns. So here we have our middle numbers matching, and our outside numbers gives us the size of the answer. So now that we've got that, we know we're aiming to create a 1 by 3 matrix. So we're going to have 1, 2, 3 values in there. The other thing that can be useful to know is just like the column and the row size has to match, more often than not, the labels also match. So that means if we look here on our matrix C, we are labelled E, F, G in order as we work down the column. So we can take that to say our values here as we work across the row are also in order E, F, G. And what the information is that we're putting in here is about his travel. Okay, so he travelled once on section E. He travelled twice on section G. There was no travel on section F, but we can't just leave it blank, so we represent that with a 0. And that gives us our matrix M as required. Okay, the third and final example, another VCAR question from the 2017 paper. And again, this is question 1 from paper 2. So here we have a region has 4 districts, north, south, east and west. The farmers from each district attend a conference in 2017. The matrix F 2017 below shows the number of farmers from each of the 4 districts who attended the 2017 conference. So we can see that there. What is the order of matrix F 2017? So again, we start off with a nice easy question. The order of our matrix, we've got 1, 2, 3, 4 rows and 1 column. So 4 by 1. Part B, how many of these farmers were either from the north or the south district? So reading from our matrix, our north district and our south district, we've got 36 from north, we've got 20 from south, so there's a total of 56 farmers from both those districts. The table below shows the cost per farmer for each district to attend the 2017 conference. Write down a matrix that could be multiplied by F17 2017 to give the total cost of all farmers who attended the conference. So we want to use the information here in this table to construct a matrix equation that will give us total cost. So remember before we said total cost means we want to end up with a single value. And so that means we want to end up with a 1 by 1 matrix. If our F2017 is a 4 by 1 matrix, then that tells me I need to multiply by a 1 by 4 so that I end up with a 1 by 1. Remembering rows and columns have to match. Outside values give you the size of your answer. So you might notice this is quite repetitive where they've asked the same type of question in all 3 examples. So knowing how to identify those keywords will mean it's much easier for you to know you're on the right track. So I need a 1 by 4. And much like before, we can look to our labels from our column matrix here, north, south, east, west, and know that the labels should correspond. We are looking to find the total cost. So we're looking to take the cost per farmer and multiply that by the number of farmers from north. So that means my cost for north, for south, east, and west will become those elements in that matrix there. Okay, part D. The number of farmers who attended the 2018 conference increased by 25% for each district from the previous year. Complete the product below with a scalar so that the product gives the number of farmers from each district who attended the 2018 conference. Okay, so a scalar, remember, is a single value that's a multiplier outside the matrix. So we just need to multiply everything in this matrix, this 2017 matrix, by the same value. That value, we have an increase by 25%. So much like before, increase by our percentage means we're doing 1 plus 25 over 100. So our big R value is what our scalar value is. And so we can say we should multiply that by 1.25. Okay, that's it for these examples. Please let me know if you do have any further questions to do with these, and we can look at them in class tomorrow.